Okay, so what we're going to do now is look at the walking cycle from the perspective of each joint one at a time through the different phases of gait. And so this one will be focused on the ankle. And so what we're going to integrate is this visual image of the skeleton with the joint angles, which we have here. And this is specifically the joint angles that we're going to obtain are the hip, or the hip here, the knee, and the ankle. So we'll start right now with the ankle. So we look at the graphic. We notice here dorsiflexion is up, and plantar flexion is down or negative. So positive is dorsiflexion, plantar flexion is negative. We notice we land really with a little bit of dorsiflexion, and then rapidly we plantar flex to about 10% of the gait cycle. And at 10% of the gait cycles, we go to foot flat, and then we dorsiflex up to about 50% of the gait cycle, and then we plantar flex until 60% when we lift that limb off, and then during swing, we basically at the ankle, the roll is for the ankle to basically go from plantar flexion back to that slight amount of dorsiflexion position that we have at initial contact. So let's see how that plays out here on the video. And so if we kind of bring the person back, so we see the left leg here landing, we can see just as it's landing here, we have initial contact, the ground reaction force is recording there. We notice that there's just a slight amount of dorsiflexion of the whole foot relative to the tibia. So then as we go forward, there's foot flat right about there. And so as we come back here, we notice that the tibia is back a little bit relative to the foot, so that's a slight amount of plantar flexion. So at foot flat, there's a slight amount of plantar flexion. And then what's going to happen next is while the foot's stationary on the ground, so we have that here, so we've gone from, so we go back, so initial contact, a little bit of dorsiflexion, and then we go to foot flat, a little bit of plantar flexion. That's at 10% of the gait cycle. And then as we progress toward heel off, what's happening is the tibia is progressing over a stationary foot. So as it's progressing here, okay, then about 30% of the gait cycle, we notice that the heel starts to come off, all right, and that's going to get us to the point where now we're wondering when plantar flexion is going to begin. So now we're as we go from 10% right here, where we have foot flat, as we progress from foot flat, that's 10%, so past 10% we enter the mid-stance phase of gait. We go from the mid-stance phase of gait when the heel comes off right here, now we're into late stance. And during late stance phase of gait, what's going to happen is the ankle is going to have peak dorsiflexion occur, and then we're going to start to transition from peak dorsiflexion into plantar flexion. So here we're going to go now. Now we're definitely into late stance. So here we've got, so mid stance is occurring right, the end of mid stance is right about here. So the opposite leg has to get just in front of the tibia for the heel to come up. And so as the heel starts to come up, that's the end of mid stance and the beginning of late stance. And then just before, so right about here, just before the opposite heel hits the ground, we're going to have the initiation of plantar flexion. So just before the end of late stance, we'll have the initiation of plantar flexion. So let's look at the graphic here again. And so essentially 50% of the gait cycle's right here, okay? And what we can see is in terms of the gray lines, the plantar flexion just started just before 50%. So remember, 50% is that point at which the opposite heel hits the ground. Now, the red lines was actually Luke walking, and Luke actually started a little late, and he would be considered abnormal and when he started his ankle plantar flexion, essentially. So we can see here, typically what's happening is Luke's just a little bit late. He starts his plantar flexion right at the point of opposite heel contact, or initial contact on the opposite limb. Okay, so normally people would start just a little bit earlier than that. And then essentially we'll watch here. So then as we go from heel contact on the opposite limb, so as we go from that to where he lifts his left leg off, that's pre-swing. And watch what during pre-swing what's happening is now he's rapidly plantar flexing. So right here, if we notice now the tibia, the position of the foot relative to the tibia, it's plantar flexed, and even a little bit more just as he goes to toe off. So if we look at the kinematic diagram, we can see here is basically he was at peak dorsiflexion around 50%, and that in terms of degrees, that's about 10 or 15 degrees, and then he's going to move rapidly into plantar flexion. These lines represent when toe off is occurring, and they're going to peak in terms of plantar flexion around 20 degrees. And so essentially we have this rapid plantar flexion that's taking place. Now let's see what happens to his foot. If we can pick up this during swing phase, initial swing, mid-swing, and terminal swing, this transition of the ankle from plantar flexion to dorsiflexion. So there's that plantar flexion position, and then it pretty much stays plantar flexed, but now just as the toe is clearing the floor, so right here we have that toe clearing the floor there. So at the transition from initial swing to mid-swing, we can see toe clearance is really important. And so at that point, we need some amount of dorsiflexion. And basically, Luke kind of recruits some of it, but you can really see it right here, right there. He starts to dorsiflex, and now he's clearly in a dorsiflex position by when we get really at the transition from, let's go back here, transition from mid-swing to terminal swing. So remember, that's when the tibia is vertical. So as we make that transition, now right at this point, the ankle is clearly dorsiflexed, preparing for initial contact on the ankle. So that's the kinematics. So let's go now and talk about what the moments and powers are. So we're going to switch slides here and go back to the beginning. So now we've gone to kinematics, but what are the muscle control that's kind of allowing those kinematics or driving those kinematics to happen? So initially, we have initial contact now to know it. So we're going to talk about the kinetics, so what the moments are. So at this point, what we have here is we have a joint center here represented in green at the ankle. The ground reaction force is posterior to that. So essentially this is an external plantar flexion moment. And so what we'll find is an internal dorsiflexion moment. And this is the knee moment, or the moment graphs for the hip, knee, and ankle. We can see here at the ankle, negative is a dorsiflexion moment. We can see there's a slight dorsiflexion moment here internally, which means the muscles like the anterior tib are eccentrically controlling the descent of the ankle. So let's watch that as it goes toward foot flat. So notice now that the moment arm's gotten smaller, but look at how large the ground reaction force is, and that it's still posterior to the ankle joint center, and so it stays posterior. There's foot flat right there. So just after foot flat, then the ground reaction force transitions. So this is at this point there's no ankle moment. So if we were to come back to the graph, that would be at this point right here where the cursor is. Okay, so essentially that's 0. Okay, because the moment goes to 0 when there's no moment arm. And then we can notice now what's going to happen is the ground reaction force passes anterior to the ankle joint center, and so now we're starting to recruit the plantar flexors. So as we have from initial contact to foot flat, the ankle muscles we're recruiting are the ankle dorsiflexors, or the anterior compartment muscles, the anterior tibialis muscle being one of the key agonists that would eccentrically control the plantar flexion of the ankle during the weight acceptance or limb loading phase of gait from 0 to 10% of the cycle. So once we get past that phase, now we're past limb weight acceptance or 10% of the gait cycle. Now we're transitioning into mid stance. As soon as we transition into mid stance, what's happening now is that the control switches from the anterior tibialis or dorsiflexors to plantar flexors, because now the external moment is dorsiflexing the ankle, and so the internal moment then would be the ankle plantar flexors like the soleus and gastroc muscles that would then control the advancement of the tibia over the fixed foot, because in this case it's really the foot is fixed on the ground and it's the tibia moving on the ankle. And so we can see here, as the ground reaction force continues to change direction and shift to the forefoot, so we go all the way here. Now by mid-stance, the transition from mid-stance to late stance, what we see is that the ankle now is in significant amount of dorsiflexion, which was controlled by the soleus and gastroc muscles, and the knee is straight now. So then the recruiting of the gastroc muscles at the knee joint, they're fully lengthened, and so they're at a good force-length relationship. And we can see now with the forefoot pressure, we're going to start to get heel off. So essentially, the heel off mechanism is happening here. So we have peak dorsiflexion. So the muscles start to move toward plantar flexion and rest. The dorsiflexion that's occurring start to move toward plantar flexion after heel off. And as we get into late stance, what's happening is then the ankle's about to execute a push-off to push the trunk center of mass upward and forward. And so we can see that transition occurring here now. We can imagine at this point, this is a significant plantar flexion moment. We see this external dorsiflexion moment of the ground reaction force, the long moment arm at the ankle joint of the external load, resulting in a dorsiflexion external moment that would then need to be resisted by a ankle plantar flexion moment internally. And we can see then as we go toward the end of late stance, what we need to have happen is for that to really transition from an eccentric contraction to a concentric contraction. And as we see that loop now goes into some more plantar flexion, that the moment's quite high, because here the load's quite high. So why the load's quite high? He still is plantar flexing, so he's using a significant concentric contraction to push his body, his trunk upward and forward as he transitions to the opposite leg. And that's why we might also call pre-swing push-off, because he's pushing off with his ankle to try to give an impulse that travels through the knee up to the trunk that forces the body forward and upward. So there he ends by pulling off his foot, so his toe comes off, so the ground reaction force is no longer a factor, and essentially the weight of his foot is causing the muscle contraction. And so at this point, as the speed and weight of his foot is inertia that he must overcome, so he overcomes that inertia as he goes into as he goes from initial swing to mid-swing to dorsiflex his foot, and then ultimately use the dorsiflexors to prepare for initial contact. So in review, the key elements of the kinetics of the foot are from the weight acceptance phase. It's all about the ankle dorsiflexors, which eccentrically control the lowering of the foot to the ground for foot flat. After the transition from foot flat to mid stance, there we shift to eccentric control of the soleus muscle in particular, and then at times the gastrocnemius muscle to control the forward progression of the tibia over the fixed foot. And then as we get into late stance, there's a transition from eccentric control to a concentric contraction as we get into late stance, and the ankle starts to plantar flex. That plantar flexion then is associated with a significant push off, which moves the trunk upward and forward. And then during swing, we have only the inertial properties of the ankle to overcome, in which the dorsiflexors are sufficient for that, and they basically position the foot for initial contact as the next gait cycle begins.